everyone, welcome back to the ultrasonic kit for Arduino tutorial series. Today we'll meet a commonly seen device, Stopwatch. It's a small but useful handheld timepiece. If you want to have a running competition with your friend, it can help you time the race accurately. We can see many LED displays here and there in daily life, and a 4-bit one often can be seen in places such as airport, sport field, stadium, etc. as time display. In this experiment, we use a 4-bit 7-segment LED display to show the time counting, which is a simulation of a stopwatch. Let's get started. First, let's take a look at the experimental phenomenon. We can see on a 4-bit 7-segment LED display, by default, 0000 is displayed at first, and then the number increases automatically by 1 each second. Now let's check out what components we'll need in the experiment. The SunFounder Uno board, a breadboard, a USB cable, some jumper wires, 8 220 ohm resistors, and a 4-bit 7-segment LED display. Here, if you use a common anode 7-segment LED display, connect the common canal pin to power. If a common cathode one, connect the cathode pin to GND. When you use a 4-bit 7-segment LED display, generally, its common anode or cathode pin is to control LED display. Actually, only one LED works at one time. Since the electronic scanning is really fast, what we can see is 4 LEDs working at the same time. In this experiment, we use a 4-bit 7-segment LED display to simulate a stopwatch via programming. Now let's build a circuit. Plug the LED display on the breadboard. Connect a 220 ohm resistor with pin A of the LED display. And then to pin 2 of the SunFounder Uno board. Another resistor to pin B and then pin 3 of Uno. A resistor to pin C and Uno pin 4. One to pin D and then Uno pin 5. Another to pin E and Uno pin 6. Then a resistor to pin F and Uno pin 7. One to pin G and then Uno pin 8. And the last resistor to pin P and then pin 9 of the SunFounder Uno board. And hook up pin D4 of the LED display to pin 10 of Uno. D3 to pin 11. D2 to pin 12, and D1 to pin 13. So the circuit is completed. Open the IDE and type in the code. Since the code in this experiment is quite much, to save time, I'll just show you the typed code, but I'll still explain in details. Just be patient and you'll learn much. Let's begin. Define the header file. Here is to connect A to G, P, and D1 to D4 with pin 2 to pin 13 of the Uno board. Use a long variable n here. Set its initial value as 0. N represents the value displayed on the LCD display. For example, when n equals to 0, 0, 0, 0 is displayed. The maximum value is 9,999. Set the integer variable x as 100. Zdel as 5. The value is the degree of fine-tuning for the clock. Set the integer count equals to 0. Here, count is a count value that increases by 1 every 0.1 second, which means 1 second is counted when the value is 10. The original value is 0. First, set up. The function pin mode we've mentioned before is one to define the input or output of a pin. Here, set all the pins of the LED display as output. Initialize the time span of timer 1 as 100,000 microseconds, namely 0.1 second, which is the count interval. The sentence attach interrupt ISR is to attach an ISR function to call when there is an interrupt. ISR stands for Interrupt Service Routine. Here we use an add routine. Void add. The original value of count is 0. Count plus plus equals to 1. Keep the counting till 10 because one LED can display a maximum of 9. If count equals to 10, which is 1 second, the following statement will be run. Count equals to 0, which means count from 0. Then n plus plus equals to 1. When n equals to 10,000, n restores to 0. Then use a loop function to circulate the process of lighting up and turning off an LED. First, call the function clear LEDs. Now let's take a look at the function. Void clear LEDs. Use digital write to set the pins A to G and P as low, so as to clear an LED screen. Then back to the loop, call the function pick digit x. The value of x is 0. Now let's take a look at the function. What the function pick digit integer x does is to light up an LED x. The 7-segment LED display is a common cathode 1. So also use digital write to set D1 as high and the LED will go out. Similarly, set D2 as high so LED D2 is off. And set D3 and D4 as high so LED D3 and D4 are off. Switch X is a cyclical function. It controls the flow of programs by allowing programmers to specify different code that should be executed in various conditions, which is defined in Arduino.cc. It includes a switch expression, then case constant expressions followed by a statement for each. When the expression is the same as the constant one of a case, the statement after the case is run. If there is no match, the statement after default is run. When the case statement is done running, if there is a break statement, exit the switch cycle. Otherwise, the running is on till all the case statements are run. So here use a switch case to control the LED lighting up and going out. Case 0. Set D1 as low so the LED will light up. Light D2 up. And D3. Default, so there is no match. The statement below is run. That means to light D4 up. Then back to loop. Light up LED D1. Call the function pick number integer x, and x equals to n divided by 1000. For example, if n equals to 1345, then 1345 divided by 1000 equals to 1.345. Since x is defined as an integer, the result is taken as 1, which means 1000. Now let's take a look at the function. The function is to control the LED to display numbers. Here, x is the number to be displayed. It is an integer from 0 to 9. Here also use a switch case statement. If x does not match with any of the case constants, the statement after default will be run. Call the function 0 to display the number 0. And the subsequent similar statements from 1 to 9 are added to display from 1 to 9. Now let's take a look at the functions. Take 0. The function void 0 is to control the high-low level of LED. Use digital write to set A to F as high, G as low. Based on the pin diagram just mentioned, when A to F is high and G is low, the number 0 will be displayed. Then set A, D, E, F, G as low and B and C as high. Based on the pin diagram, 1 will be displayed. Similarly, set C and F as low, A, B, D, E, G as high, and 2 will be displayed. Then to display 3, set E and F as low and A, B, C, D, G as high. So the function void 4 is to display the number 4, void 5 to display 5, void 6 to display 6, void 7 to display 7, void 8 to display 8, and void 9 to display 9. Now back to the loop function. So as we've learned before, n divided by 1000 means the number displayed is 1000, which is displayed on LED D1. The initial value of n is 0, that is, the x in the pick number integer x is 0, thus displaying 0, which indicates 0,000. Delay 5 milliseconds. The value of DEL, which means delay, we've set with integer above is 5. Clear the LED screen. Similarly, use pick digit x to light up LED D2. Call the function pick number again. With the same way in getting the value of 1000, obtain the value of 100. For instance, assume n equals to 1345, then get the remainder, 345, divided by 100. The value is an integer, so the result is 3, which means 300. The initial value is 0. Then delay 5 milliseconds. Clear the screen again. Light up LED D3. Similar to the value of 100, get the value of 10. Also, the initial value is 0. Again, delay 5 milliseconds. Clear the screen. Then light up LED D4. Set the value of single digit. The initial value is also 0. Again, delay 5 milliseconds. That's all for the code. It is long enough, so let me sum it up. Setup. Set all the pins of the LED display as output. Set timer 1 as 0.1 second. Run the following functions. So add will be called when is 0.1 second. But before 0.1 second passes, add is not called yet. Then use a loop function. The 4 LEDs are displayed as 0, 0, 0. Wait for a while. 0.1 second later, indicating count equals to 10, call the function add. Then n++ equals to 1. Because 1 is smaller than 10,000, it will not restore to 0. Run loop, and the LEDs will be displayed as 0001. 0.1 second later, n increases by 1. N plus plus equals to 2, and the display will become 0002, and then 0003, and on till 9999. N increases by 1 every second, and the number displayed increases accordingly until n equals to 10,000 and n is 0 again. Then the counting starts from 0. Compile the code and check whether there is any error. Then connect the SunFounder Uno board with your computer to upload a sketch. Now check the results. We can see on the 4-bit 7-segment LED display, by default 0000 is displayed at first, and then the number increases automatically by 1 each second. So that's all for the experiment. Though the code is quite much, it is not that difficult as it seems. Just keep your patience and you'll find it as easy as cake. In this ultrasonic series, this lesson will be one of the last ones. You may have noticed that the experiments are really easy but applicable in daily life and so interesting. So keep your learning then. Same as usual, for any questions, email us at support@sunfounder.com or visit our website sunfounder.com to leave comments or messages. Thanks for watching. See you next lesson.